Yeah, thanks for having me, Gigi, and thanks for having me, all of you. Lovely to be back here again. We're going to be talking about containers today. And before we get started, I want to ask everyone who knows about containers or Docker. Have you heard these terms before? Quite a few of us. How many of you use this in day-to-day at your work or frequently enough? Yeah. And have you tried using the containers on AWS, just out of curiosity? A few of us, all right? So in today's talk, we're going to look at containers. We're going to go through the whole introduction of containers. I will introduce it with some slightly different concepts so that it makes things easier for everyone, regardless of what level you're at. And we'll try to keep this at a very easy level for you to understand containers, the concepts on AWS, when you want to run the same container on Amazon, and we'll look at a demo afterwards. Let's get started. So, about me, my name is Hital Kasrani. I think the jacket there and the jacket here is the same, so you know you're getting the same person. So I'm part of CCL. I'm an AWS Cloud DevOps engineer at CCL. I've been there for 2.5 years now, and I've worked with Amazon for about 4 years. In the last couple of years, I grabbed up a bunch of these certifications. That's how I got the jacket, because I have 12 Amazon certs, and I think there's a few more that came out recently. So if you have questions about certification on AWS or you're interested in that, you can feel free to reach out to me afterwards on LinkedIn or afterwards after the talk. Happy to talk about that, give you some resources and tips and tricks on the exams. Next thing. So containers with Docker. I won't talk tech for now, but I want you to think about containers like this. Tupperware. Who likes Tupperware? A lot of us. You know, I was very picky about what kind of Tupperware or brand of containers I got as a kid, because some of them were a lot better than the others. Or think of it like a literal container, right? They come in different shapes and sizes. They have different uses, some with multiple partitions, some with just one partition. And you can fill them up with all sorts of things. A lot of different food for your lunch, or you could just have a single wrap or just one dish with some rice and some veggies. So you can see the image here, and if you can't see the slides, just let me know on this side. You can see the slides here. There's a bunch of different ways you can partition them, or sometimes they have different partitions so that you can store a bit of your food or a bit of veggies in one area, your mains in a certain area, maybe a bit of dessert. I mean, if I had a container, I'd probably just fill it up with dessert, but people say that's unhealthy. Or I'd like to compare it to a thali. This is a traditional Indian dish in some way, I would say. In India, it's a dish where you have a variety of other Indian dishes served together on one big platter, and the other ones are in very small portions. There's a lot of food there. And there's a few companies I remember back home who like to serve thalis like this. They call them the Maharaja thali, like a massive plate with a lot of different foods and trying to cover up a bunch of different flavors, textures, and also all three parts of your meal. So containers are like that, different shapes and sizes, different kinds of food, different kinds of dishes. And what this essentially means in technology is using your software and building it up in a way so that you can run that anywhere, regardless of the OS or anything else. Let's say, for example, how many of you play games? Some of you guys, right? For example, if I have a PC game, I can't run that on PlayStation or Xbox. Similarly, if I have an application made specifically for macOS, I can't run that on Windows. They need to be built specifically for each software. What containerization does is it allows you to bundle up your software in a way so that you can take it out like a container and give it to someone else, and they can run it the exact same way, key being the exact same way, regardless of the platform. That's what container technology is. It's like a thali or a tiffin box, or these are traditional words, more traditional words I'd use back home, or like a Tupperware box that you take out for your lunch. You can build it once, or you build it everywhere the same way, and you can run it anywhere, regardless of the kind of software your host is running, or regardless of the computer if you have the right technology. That's why it's so useful. How we do this in technology, there's a bunch of jargon here called virtualization. It just means taking a computer's hardware, divide it into multiple parts. Then you have containerization, using or bundling your software into one container which will run on like a virtualized host. So you take your laptop, divide it into a bunch of parts, and within that one part you can run this bundled software specifically. They can run under an isolated space in your operating system. That's what containers are. How you do that is through a tool called Docker. It allows you to build, share, and run containerized apps using a Docker file. That's one of the examples. It might not be the best, but it's basically giving a base image, giving it some commands, and telling what do you want to do when you run the application. So fairly simple, can get very complicated. We want to keep things simple for now. So we'll just think of it like taking a base image, giving it some commands, and running it. And once you have built an image, you can store it on a registry, kind of like GitHub, but instead of your code, you're storing your container. It can be stored on Docker Hub or ECR. Now, one thing I want to highlight is Docker is one of a few other container technologies that I've heard about. There's quite a few of them, so if you're curious about them, feel free to research them. We'll have a look at some of the containers in a bit. So containerization, but I will reiterate again, containerization is like a Tupperware box or like a literal container, different shapes and sizes, but it's used for software. You can have different kinds of software running on it. Regardless of where it goes, you end up eating whatever's in your Tupperware, and you end up consuming what's in your software. So you can take it anywhere and you can give it to anyone. It'll run the same everywhere. Now, we want to run this on Amazon as an example. So let's look at some of the concepts you need to know for running this on Amazon. ECS is the service that runs containers on Amazon. It's called Elastic Container Service. Elastic just means it's scalable. It can scale from one to many instances, or it can scale up if needed. And it's got a bunch of different concepts. You've got a cluster, a service, a task, and a task definition. I was thinking a bit about how I could describe these, and I would say a cluster is similar to a restaurant chain. Sorry, everything's food related today. I just went with the theme because it just seemed more appropriate and easier to understand. Appropriate only for concept-wise, not comparing food to software. But a cluster is like a restaurant chain. You can have multiple of them everywhere, and under that comes a service. It's like an all-you-can-eat buffet. Endless food until I stop the timer or I can't eat anymore. Or it's like having the same meal every day. Some of us do that. I personally can't do that. But then you have a task, which is like a single meal. Not an all-you-can-eat buffet, just a single meal. And then you have a task definition, which is like a recipe. Let's start with the task definition or your recipe. You can have one or more container configurations in your task. Generally, I stick to one configuration when you're playing around, and you can build it with your console or the CLI. I put console or GUI. That was my mistake. Didn't realize what I was writing there. Then you have a runtime, which is kind of like telling you a recipe. I want to cook this in a microwave, or I want to cook it on a stovetop. You can run it on Fargate or EC2. That's basically like a computer, but different kinds of computer options. Fargate means you want it at the restaurant. You don't really want to worry about making the recipe. You just want to eat it, right? You tell them, I want this dish. I want to have it now. And if you're at home and doing the same thing, you have to cook everything yourself, manage everything yourself. That's running it on EC2. How many of you know about EC2? A few of us, right? A good chunk of us. But just to explain again, EC2 is basically how EC2 stands for Elastic Compute Cloud. It's basically how you run virtual machines on AWS. So if you use EC2 as an option, all that means is you're going to manage the instance, you're going to cook your own recipe. Whereas if you go to Fargate, you just tell it, I want so much compute capacity and I want to run my stuff on there. It's the same as going to a restaurant, telling telling the waiter or the cook, I want this dish. No, doesn't matter how you make it, I'll just have it. And then, if you go on EC2, you manage the infrastructure yourself and so on. So we're going to look at Fargate because it's an easy way to get started. No instance management. You just tell it how much compute you want. I can't zoom in much over here, but I'll show you the exact same sample in a bit. You can look at it as a JSON file if you try following the sample later, or you can look at it within the AWS console. We'll look at that as well. Next, we have a task, which is the meal. It's just running your task definition. So it's kind of like using your recipe and cooking your meal. And so a task will run once until it's completed, kind of like a program, because that's basically what it is. It's taking your software, running it once. If it fails, it fails. If it gives a success code, it gives a success code and finishes there. And then you can also check stuff like configuration, logs, networking, and all of that. Once you deploy a task, we'll look at that. Then comes the service, which is the buffet. Sometimes my favorite, the buffet. No, maybe the service sometimes as well. You can run one or more tasks continuously. Important part being continuously, kind of like a buffet. That's why endless food, endless running your software. If one fails, another will be spun up, kind of like Hydra from the Marvel Universe. If one falls down, another one shall take its place. Until condition being the ECS circuit breaker runs, which is configured by default. What that means is if your task keeps on failing, or if you have a bug in your code for 5 consecutive times, the container service will stop running your task. And this is good for long-running applications like web servers or anything that you want to be running indefinitely. And you can configure stuff like auto-scaling, load balancing, and the network for your tasks over here. So when you want something long-running, you want to have it behind a load balancer, or you want to have multiple tasks run the same thing behind a load balancer. That's when this is more helpful. Lastly, you have the cluster or the restaurant chain. It's just a logical group of putting all your tasks together under a namespace or so on. It's basically like a restaurant chain. It's a name for everything that's under the containers. And I said it contains the infrastructure, network, and monitoring, but when you deploy it, and we'll look at this in the example, it's basically just like deploying, I want a name for my cluster that'll group everything under so-and-so software name or so-and-so cluster, and I can give it a runtime saying this will only use Fargate or this will use EC2 for the build. Now you need to set up a cluster to run a task or service, which is quite important. You can't do that without having a cluster set up. Sometimes also you might have to set up your network, but very luckily for us, AWS provides a default cluster and a default network, so you should be good to go with this on a basic account. I just realized I forgot to put stuff about costing, but we'll have a look at that if we have enough time. I'm going to look at the live demo very quickly. Whoops. We'll jump to that. So the source code is from AWS samples, deploy Streamlit app. You can search for that once you're at home, or I can put the link later. We'll jump to my console and let me know if you want me to sign in again. So this console looks a bit different, but I select my account and I just go into it. If you have your own AWS account, you'll just see what I see right now once this loads. So let's search for ECS. Jump there. I've already deployed everything, but I can quickly try deploying another one potentially. Actually, I don't want to configure a load balancer, which I'll show you here, but we can look at that. So let's create a cluster. We give it a cluster name, live demo cluster. It'll create a default namespace. I can tell it what infrastructure it will run on, kind of like where I want to cook my food. I'll just leave it on Fargate, which says it's pay as you go. If you have a tiny workload or a batch or a burst workload that you want to run, that's good. The good news for us is this can be incredibly cheap compared to running an EC2 instance, and whether or not you run a task on your instance, you're still going to have to pay for your infrastructure. If you want monitoring, you can enable Container Insights. It provides more monitoring details. And if you want to set up stuff like encryption, you can do that here. So for the time, I've set up monitoring just to see if I can show you anything. That'll spin up something for us over here, which will create the CloudFormation template. We'll wait for this to load up. It might take a bit. So it's going to deploy a stack somewhere here. This one here, create in progress. We'll just wait for that. And in the meantime, in my code base, I have so this is the same code base as the example I showed you. I've just made a few changes, removed some authentication stuff. We have an application, we have our Docker file, which is the important part. Very simple, right? It's a Python app, so I say I want to use Python as my runtime. I want to expose a port number because I want to run my app on a certain port. I give it a work directory, copy my requirements, run an install, copy all my build folders or whatever I need to run a build. So if it's npm, you'd probably run all your build commands like run npm build and copy all the build folders. And at the end, you'll have a run or a cmd command, which will be the entry point to running your app. So all this will do is do streamlit run app.py on this Docker app. Once I've built the container, you can push it to ECR. So if I go to ECR over here, repositories, I can create a repository. So I've created one here, and I can do view push commands over here. That's going to show you all the commands you need to run to push it to Docker on, not Docker, push it to ECR on here. So prerequisites, obviously you need to install Docker, which you can do from the Docker website, docker.io. And you need to build your image. Once you've built your image, so that's the Docker website, download it from here. We're going to go a bit quick because I don't know how much time I have left. So once we have our cluster, we can give it a task. I will create or service. And I go to capacity provider, leave it as Fargate, leave everything the same. I want to run a service. Yes, this is important. This is going to ask me for a family, which means it'll ask me for the task definition I want to use. I've got a pre-built one. We'll look at that in a second. I'll give it the private app example, latest revision. live demo service. Desired tasks. I strongly suggest sticking to one unless you want to test something, because otherwise you'll have multiple tasks and it'll charge you more than you require. Especially if it's a dev thing, just one should be fine. You don't have to configure any of these. Networking, generally go with the default VPC. I've got a pre-configured one, so I'm going to use my pre-configured VPC. And I'm going to, in my case, select the public ones just because I want to run it with the IP. If I run this on a private subnet, I have to disable the public IP settings. That's one of the important things. I've got a pre-created security group, which just means it decides what ports are open on my instance or my application, and it allows access to those specific ports. So I'm going to use my test security group I pre-created. I'm not going to configure load balancing right now because it can be tricky at times, and I don't know how much time I have, but if you want a load balancer, you can create everything here. The caveat with this is if you want a private application and a public load balancer, which is generally the way to go, you have to pre-create your load balancer in a public subnet. You have to pre-create all of the resources and just select the pre-created resources here. So if I use an existing one, I can select the existing listeners and try using the existing target group. It may or may not work. Maybe it will, maybe it won't. But I've already got something configured the same way as here. So using an existing load balancer I created, which I can search for by searching for load balancers over here. And once you create the load balancer, it'll ask you to create a listener or a target group. If you're stuck, you can try creating it over here. All it's doing is setting up what ports you want to use. Most of the time set up port 80 unless you're using a custom port, which you will edit in your target group. If you do auto scaling, you can set it up here. We're not going to set that up. Very simple target tracking, minimum and maximum number of tasks, and scale based on CPU utilization or the number of requests you're getting. Scale in time, scale out time, and scale in time. So scale out every X minutes, scale in every X minutes, and at what amount of utilization do you want to auto scale. So I'll skip that. I will skip this and just create my service. While it creates my service, I will show you the task definition. And if I click on this one, the latest one, when I select, so when I said create a new task definition revision, that's the same as creating a new task definition. I give it a name, I give it what kind of infrastructure it'll require, stick to Fargate. If you want to use anything that's not Linux and x86, you can select it over here. Generally, I stick to Linux and x86, which does all my work, unless you're running something that is Windows specific or ARM specific. You can select those as well. This is the important part. Very simple for us right now. I just tell it how much vCPU I want. And the gigabytes next to it over here is basically the amount of RAM. So this is the RAM and this is the CPU processing power I need. Most tasks should be happy with 0.25, 0.5 or 1 vCPU. It shows you the compatible types with that. So I'll stick to 5 vCPU and 1 gig. If I go 0.25 vCPU and lesser, I can choose something like 0.5 gigs, which will be cheaper. So you can go down to a very small task. You'll need a task role and you'll need a task execution role. Sometimes they're created by default. If not, you can search for the task execution role on the AWS website and it'll give you information on what you need for that. As far as I remember, most of it was set to default, but the link that I have will also show you what you need to change on there. I think that should show you what you need to change on the code base as well if you need to update that. Then I give it the container name, I give it the URL of my image. If this is from Docker, I'll just say something like nginx:/latest. This will pull a public image, which I can find on the ECR public gallery or dockerhub.com. I think so, that's the website. So a lot of public images over here that I can select. If I am using my custom image, it'll ask, do I have to re-sign in? Probably do. It'll ask me to sign in again, which should be fine. So if I have to use my own image or my private image, I go to ECR, check my uploaded image by following the steps on ECR, and let's find where, oh, it was there, repositories. So that was a permission set that I'd set up. That's ECS task definitions that we were going through. This is how it looks in JSON over here. So this is like a big thing that's built up once I select my container and everything. But let's go back to the repositories if I can find it. And yeah, so if I click on this, I'll get a URI that I can use. Important part is you need to have connectivity to the internet. So stick to using the default VPC and try using the public subnet first, but be careful if you use that because you're going to have public IPs and publicly accessible stuff, which you don't want to have until, or you want to secure it a bit. So have a look at that. So you give it your image URI here, essential container. If you're using private registries, you can select, such as your Docker Hub stuff, you can select authentication and store your username and password in Secrets Manager and deploy that there. You choose your container port, so what port you want to run your task is going to run on, what protocol it's using, give it a port name, app protocol, so on. That's why this is kind of like a recipe. You provide it with all the details you need to run your software. And if you need environment variables, you provide that here. And you set up logging and such from here. So I'm just gonna highlight through all this. I don't really need to set up anything with storage or monitoring right now. So let's say I have my container, I built like a basic Nginx container, or I built the same container that I built right now. I'll go to clusters, live demo cluster, it's my service, and it says over here one completed, one desired. That means the amount of tasks I want, none tasks pending, and one is running. If it was failing, it would show me it failed over here. And if I click on this task here, which is a bit funny because of the console, I can go down here. If it's a public task, I can open that there. If it's a private task, well, didn't allow me to access that. Let's see, 8501. There you go. Because I ran on the 8501 port, it asked me for that over there. This is just a sample image generator using some AWS AI tools. I think the link that I've given for GitHub will have another tutorial on that. So I'll say cat in a hat. And it'll run an API call for AWS Bedrock to generate an image. So that's kind of the sample app I decided to stick with. There you go. Fancy cat, fancy hat, all running on containers. I can put this behind a load balancer and it'll run over there, but that's kind of the gist of it. It's like So here's the sample code. You can keep an eye on that. But to conclude, containers is basically like having recipes. You create a recipe, which is your task definition. You can run it as a task or a service on AWS. And if you run it as a service, you need to make sure it's in a named cluster. Your recipe can have different kinds of compute and compute monitoring and other options for running your application. And containers are basically like what we discussed, Tupperware, a literal container. Think of it as food. It'll probably make things easier, make you a bit hungry as well, but we won't talk about that too much. Thanks for having me. And if you could please fill out the survey here, that would be very helpful to us. Barbara, do you want to take over?
Thank you. Are there any questions?
Yes, questions. Cab, do you want to go first?
Yeah, firstly, I think I have like 2 questions.
Yeah, go
the
for it.
first one is, because the container registry is called ECR, right?
Yes.
Yeah, what would be the difference between managing your container on there and managing it on Docker Hub, for example?
Docker Hub is a public registry. ECR gives you the option to have a public or a private registry. Generally, ECR works a lot better with ECS because it's AWS and AWS. That's the main difference. If you're already paying for Docker Hub, you can, or if you're an organization that pays for Docker Hub, you can already connect to Docker Hub, kind of with that private registry authentication thing. It's a little bit different, but with ECS and ECR, because they're part of the same, I guess, ecosystem, it works a lot easier. They're basically kind of like GitHub and GitLab. It's the same thing.
Okay, and the other question, I don't know if this is bordering on like too technical here, but like I think the port number like in that Docker file, was it 8501 or something?
It was 8501. If you're asking me why it was 8501,
Yeah, like,
I don't know. That's how it was set up, and that's how I let it be because I didn't want to play around with the thing too much. But you can, generally, if you're running a web server, it'll be 3000, 5000, maybe even port 80, which is why you probably asked that one. Yeah. Hopefully that answers the question. Yeah. Next question. Yeah.
So regarding the costing, right? How much expensive they use Fargate instead of EC2?
The general rule of thumb that I follow is if you think your containers or computers are going to have more than 50% of CPU utilization, stick to EC2 with the same instance size. Otherwise, look at the compute optimizer if you want, or Fargate is generally cheaper for smaller workloads. If you have anything that's longer running, EC2 will be better. In terms of pricing, you'll have to check it on the AWS pricing options because I think it's, let's see, Fargate costs. If I go to this part here, this will show me how much I pay for compute. It's based on the region per vCPU per hour and per GB per hour. It's I consider it cheaper than running it on EC2, and you can try and match it to the EC2 vCPU and memory sizes or slightly less. But if you're getting more than 50% usage, CPU utilization on Fargate, stick to EC2 then. Yeah, does that help? Or?
So one's the serverless and one's the...
Yes. And if you run EC2, you have to pay for the underlying infrastructure and everything.
Let's say if your e-commerce website, do you use Fargate or do you use EC2?
Depends on the number of users you're getting.
Okay.
It's a bit tricky. I would say start off with Fargate because it'll be a startup, a smaller company. as you're scaling and as you see that you're getting more need for managing your own servers, or you can potentially save more money managing your own server, move to Fargate. But always start off, move to EC2, but always start off with Fargate because you don't have to worry about underlying containers unless you have a use case where you know you're going to get a large running thing, or your company is already decided and has savings plans with AWS and they've decided to pay for a certain amount of compute in advance. You get discounts on the pricing. That would probably make things easier for you to run on EC2 by default.
Let's say you have a Fargate and you also have the EC2, and then both of them getting a DDoS attack, which one will become more expensive?
That one I'm not sure of. But what I can tell you in that case, to protect yourself from something like that, you want to use a load balancer and don't have a public IP like I have right now. I need to remove that ASAP because someone will probably take that IP and start DDoSing it and maybe take my instance down or something. What you want to do for that is have AWS Web App Firewall installed on your load balancer, or use CloudFront with your load balancer. And if you use CloudFront for content distribution along with Web App Firewall, you can stop stuff like DDoS attacks happening on your application. I think you can give it IP rule sets, and there's a bunch of other security protections, and you're protected by DDoSes to a good extent from that. If someone bypasses that, I'd say contact AWS support and be like, I got DDoSed. And hopefully they may be able to work around something depending on how much of the security is configured by you, because it's all shared responsibility. Certain parts will be covered by any cloud provider, and certain parts you have to make sure that your app is secure enough as well. So yeah. If you do intend or you think you're going to get DDoSed, make sure you have everything set up with a firewall, with content distribution network and such. Another question? There was one question behind, and I think one more. 1, 2. All right. Do you want to go first?
Yeah. Is there an option to create a list of trusted images? For example, in EKS you can create admission controller. So
I don't know if there's a feature for that.
If it's not a trusted image, it would fail.
It would fail the deployment.
ECS
Yeah.
has the same feature, or you need to create something, combine something with Lambda and all that.
You'll have to combine it not with Lambda, with IAM. What you can do is when you run your ECS task, you've got an ECS task execution role, which will run. There's two parts to it. One is for when the application itself, and one is for ECS to initialize the application and pull everything from ECR. If you're using external registries, I don't know what you could do about this, but if you're using Elastic Container Registry, what you could do about this situation specifically is have one registry, have your trusted containers, and restrict your task execution role to only access those specific containers. It's a bit different to having a list where you could just say, these are trusted. This is a bit more identity and access management, but probably the same thing in the end. You cannot, unfortunately, select it from a drop-down list anywhere, so you have to still give it there's no option for that. You still have to give it the exact URI. If it can't pull that, it's going to give you a bunch of errors, and there's a lot of different Stack Overflow options for that. So,
Just a quick question, another one, if you want to use compose in order to avoid using task definition on this bunch of stuff, is it possible to use compose directly now?
Docker Compose.
Docker compose and deploy ECS.
You can use Docker Compose within your app, but when you're using the task you still have to use the task definition on AWS's side. So the way it works is AWS requires a task definition to run a task or service, and that service would then use Docker Compose under the hood instead of just using Docker by itself. Yeah. Another.
And we have last
2 more questions.
Yes. Okay.
Oh well, okay.
Yeah, I have one question which I always find as in what one should make a choice between ECS and AKE. As in,
Kubernetes.
yeah, selecting between Kubernetes and selecting between Elastic Services. And I find it is almost perfectly.
Well, I don't know much of Kubernetes, so I'm going to say stick to this. It's easier. You don't have to worry about learning Kubernetes.
Depends on the volume. If you have 1 container, there's no much sense to
Yeah.
use EKS. If you have 1,000 containers, it makes sense.
It makes more sense to use Kubernetes.
EKS just because it's, everybody uses EKS.
Yeah.
I'm using the
Or
for my-
you want to challenge yourself and learn something. There's a specific, or more specific use case.
Is how much importance or weightage does the authentication apps that someone they have hands-on experiences for weightage?
The cert ads, from my perspective, it's good when you're starting out in your career, you want to differentiate or you want to learn something new. And obviously actual or real world experience is a lot more better, but it's a good way to get started and show people you're interested in learning something new, or you have the basic skill set, or not basic skills, I would say you have a growth mindset to learn more stuff, right? So that helps you get your foot in the door, and that means you're almost in. Once you're in, you get to learn more and get the actual real world experience you need, or you just want a free jacket like me. So, yeah, yeah. And last question there. Sorry to keep you waiting for so long.
So can you use transformation template to
Yes.
or Terraform template?
Yes, you can use Terraform. I don't want to add too much technical spice today. It was meant to be a very easy to understand thing. So hopefully it stayed at that level and hasn't jumped off to, well, I'll just showcase this path again. So if you want, you can give some more surveys, but yeah, you can use you can use Terraform, you can use CloudFormation, you can use CDK, probably Pulumi. I haven't used Pulumi before. The GitHub samples that I have here uses CDK to deploy the whole thing. So if you want to learn some more stuff, you can do that, or just follow the README on the AWS samples thing. FYI, that sample is slightly different to the app I showed you. I just made a few changes to it, but it's a good way to get started. Just keep in mind some of these things may cost you, some of these things may be in the AWS free tier. So you want to be careful of that and just do your research before you deploy anything. Yeah.
Thank you. Thank you, Nihat.
Thanks.
It was very
Thanks for
good.
having me.
I think doing live demo is always challenging, and you did very well. So I think the golden
Thanks.
jet fits you very well.
Thanks.
Thank you everyone for coming. Give us this.
Thanks for having me.
And it was so inspiring. You can now all jump to console and do some containers. And then, please, before you do that, please can you scan the QR code and give some feedback to us, because it's very important for us, because otherwise you can still doing these events. And yeah, that's from us. And if you will have any amazing project or something you want to share with us, you are always free to talk here as well. We will be very happy, and drive safe home. Have a good night. Thank you.
Thank you.
Thanks. Good night.